Welcome everyone to the Ontology Summit 2020. Today is May 20th, 2020, and this is the first, possibly only session dealing with WENTs, about the future of knowledge graphs. And so I'm really pleased to introduce Vinay Chaudhri from Stanford, who has been running a really very informative, very excellent series of sessions on knowledge graphs, your course. Particularly like last night's meeting. Thought that was really very, very nice. I hope that people in the, among those here today will be able to attend that, watch. But today's session is going to be about textbook open knowledge network. And so I'll hand it over now to Vinay.
Thank you, Ken, and thank you for the opportunity to participate in this program. I want to spend a minute or so first giving you the context for what I'm going to talk to you about. I'm part of this program funded through National Science Foundation called Convergence Accelerator. The program was structured in two phases. In the first phase, we were supposed to build our team, get some proof of concept data, and in the second phase, we are supposed to actually execute on the vision. The goal of the project is reflected in its name, in that it's convergence research. It's an effort to take research from multiple disciplines and reduce it to practice. The program has multiple tracks. I am part of, or our project is part of a track on open knowledge networks. There are about 12 or so projects, no, actually 20 or so projects funded as part of that track, and ours is one of them. We are roughly at the end of our phase one, and as part of the program requirements, we submitted our proposal for phase two, and we are also expected to make a pitch which can explain what we are doing in very simple and general terms to broad audiences. That pitch is supposed to be about 10 minutes, and that's what I'm practicing today. Just to present to you our 10-minute overview of the project, and I'm very grateful for this opportunity, and I'm very interested in feedback from all of you, and especially your criticism on how we could improve this pitch. Ken has structured today's session in a way that I first do the pitch, and then we have 15 minutes or so for discussion and feedback, and then there is a part two of the presentation. Frankly, part two of the presentation, I have put very little effort in preparing, but we do have substantial amount of detail, and depending on the time that is left, we can look at those details, which I think y'all will find interesting. So with that background, I'm going to get started unless there are some questions. All right, I'm going to start, and I need to time myself just to make sure that I'm honoring the time restriction. I will tell you about Textbook Open Knowledge Network, which is a joint project between Stanford, Rice, OpenStax, and ETS. We have a great team of interdisciplinary scientists from biology, computer science, cognitive science, psychology, and medicine, and we are excited to work on the problem of how might we make it easy for students to learn complex new concepts. We are interested in a student such as Ania, who is taking first-year biology. Ania's dream is to become a doctor. She wants to have a white coat. She wants to serve her patients. And when she comes to our biology courses, we hand her one of these. I hope you can see this book, heavy book in the video. And the sentiment that Ania and many other students have expressed to us is that biology is complex, the book has a huge amount of new words, and they feel lost. To solve this problem, we have developed a prototype of an intelligent textbook. And in our pilot tests, the intelligent textbooks have been found to improve student learning by 1 full letter grade. And they have been found to help underperforming students, students who are shy, who are afraid to ask questions or engage with the teacher. So what is an intelligent textbook? We define intelligent textbook as a traditional textbook, which is enhanced using a knowledge graph. Using the knowledge graph, we can build a certain number of pedagogical tools. And let's look at an example of those. So Ania is reading the book and she's in section 6.5, where the first sentence introduces a lot of complicated words, macromolecules, proteins, polysaccharides. And through this intelligent textbook, she can quickly access their definition, as well as the key facts that summarize that concept. She is able to access the diagrams, regardless of which chapter these diagrams were originally introduced in. The book also lets her visualize this knowledge and to interact with it depending on her curiosity so that she can solidify the understanding of her concepts. As she makes highlights to different passages in the book computes questions that she can use to self-test herself. For example, she kind of remembers that hemoglobins carry oxygen, but she's not sure. So she clicks on that question, and by comparing her answer with the book's answer, which happens to be the same, she has this renewed sense of confidence that she still remembers what she studied in a previous chapter. The book also helps her in comparing concepts. She can simply type these questions. For example, compare polysaccharide and a protein. In response to a question like this, the book presents her a nicely organized table where she can systematically compare these two concepts. Comparing is an important study skill, and the book makes it so easy for her to compare any two concepts. So that was a quick walkthrough over an intelligent textbook and its features. I'm actually just curious to hear, do you think this kind of thing might be interesting for students? Might they want it? Anybody?
Yes, I
Okay.
think so.
Okay, thank you.
I certainly think so.
Thank you.
I have questions.
Yeah, please hold on. I was just looking for a validation. And the challenge is that we can build this, but it's very expensive to create these knowledge graphs. And for a book of the kind I showed you, it can cost as much as $1.5 million to create a new textbook. To create a new knowledge graph. Now, that's not bad because the budget is less than the budget of our NSF program. But the real issue is that our friend Richard Barniak at OpenStax, he has 41 of these books. And our friends at Macmillan, who are also partners on the project, they have hundreds of these books. And Microsoft Academic Graph, who is also a collaborator on the project, they want these knowledge graphs for all the books that they can link to their academic graph. So our project until now during the phase 1 has been to answer these questions. Can we reduce the cost of building these knowledge graphs through automation and crowdsourcing, and whatever knowledge graph we can build, can we put it on a publisher's product path? And publishers are especially interested in scale. Can we do this for lots and lots of books? As an example of an automation technology, we have looked at term extraction. So using deep language models such as BERT, we can take these sentences from the books and identify the salient words with a precision of about 0.71. These concepts are going to make the nodes in our graph. The accuracy requirement is 100% because we have a book, but a precision of 0.71 is not bad because it's at least better than starting from scratch. We have built a crowdsourcing tool using which we can use the crowd workers to identify salient relationships between two concepts. So for example, given a sentence such as the shown above here, and the key words cytoplasm and nucleus, the crowds can help us identify the relationship between the two. And obviously the crowd input has to be denoised and properly weighted, but we can do that with an accuracy of 0.96, which is very good and very close to where we need to be. So what we learned in our proof of concept phase is that these automation and crowdsourcing techniques have promise for building accurate knowledge graphs. And we worked with OpenStax to come up with this idea that we would first prototype some of these intelligent textbook ideas in an OpenStax lab setting before we consider putting them on a product. And we have figured out a way to achieve scale and impact through new partnerships. We formed partnership with Macmillan Learning, who are going to run some focus groups for us and a beta test, with Microsoft Academic Graph, who wants to include the knowledge about books in their graph, and Dr. Guha, who is going to help us plug our efforts into Google's data commons. Going into the next part of the project, we want to finish building the tools we started building. We are going to use these tools to build knowledge graphs, incorporate them into educational apps, and at the end, conduct pedagogical evaluation. In terms of numbers, we will be working with 2 books. We will create graphs for 3 chapters. We will build 4 different ideas of these intelligent textbook tools, and we will test them with 500 students. As an example of the tool we are looking in phase 2 is to see if we can use Wix supervision techniques to automatically extract relations so that we go to the crowd workers only when we need to. We've already started work on this, and we hope to complete this during phase 2. Once we have these tools for term extraction and relation extraction, we can build a graph and we can get the graph validated through users. But one of the key things we want to address is that as we get information from this human review, we can use that input as additional training data to improve our extraction process. So it's these backward arrows which we currently don't have that we are going to build in phase 2. The extracted relations we can import into Protégé and visualize them, and we are hoping to use this as a platform for knowledge graph validation. The books that we are going to work with are Biology 2E and Psychology 2E, both published by OpenStax. Both of them currently have over 360,000 students using them. The 4 tools that I mentioned are things like questions, summaries, concept maps, asking questions. These are all the things you've seen in the demo. We will work with the focus groups and put them through iterative user testing. And once we have the winning idea, we are going to run a pedagogical evaluation where a student will read some chapters of the book without these features, and then they will read the book with these features, and we'll compare their performance. The main deliverable from our project is the textbook Open Knowledge Network. Initially, it's going to create knowledge graphs for biology and psychology, some intelligent textbook applications, and the data on the evaluation. And the knowledge graph construction tools, we are going to integrate into Protégé and make it available to the community. I want to conclude by just noticing some broader applications of this technology. We are very interested to work with other participants in the Convergence Accelerator who are looking at manufacturing and training problems because they certainly go outside the textbooks, but our technology is clearly applicable to them. And outside the convergence accelerator, we want to use the similar technologies in the legal domain. For example, for modeling contracts or for modeling tax code of the sort that Internal Revenue Service has. With that, I like to wrap up. Thank you very much and happy to take questions.
Thank you very much. So we have a few questions on the chat. Ravi, go ahead.
I'm unmuted now.
Yes.
Thank you. Vinay, several questions on the chat board that I have noted just so that I don't forget. I wrote them while reading your 2-page intro.
Okay.
The main question is that first a query, simple query. Why don't you use the word ontology, which you actually are using in doing the knowledge graph, in also using protege for things, and in extracting useful information from the books. So, and then the last part that you just now showed, it is finding relationships and also meaning of the entities in terms of terms. So that's first question.
Okay. So let me address that. As Ken mentioned, we have been running this seminar on knowledge graphs at Stanford. And many people come and talk about different ideas of what knowledge graph means to them. And there's a very rich tradition of graphs in computer science, right? So I mean, the basic discrete math course will introduce graphs, right? And a lot of things in computer science you can view as a graph, and you can call them knowledge graphs. And then it just becomes a question of, okay, what is the distinction between a knowledge graph and ontology? Or what is the difference between knowledge graphs and conceptual graphs, or description logics visualized as graphs? So I'm not sure if there is any productive way to settle that debate. I can tell you why I'm using the word knowledge graph here, and where we are coming from in this project. So before this textbook Open Knowledge Network, I worked on Project Halo, where we were trying to build ontology from a book. And the main difference between what we did there and what we are trying to achieve here is that when you approach an ontology, it is top down. You're trying to design the model of the world, and you are trying to figure out what the semantic relationships are and what the definitions are. So it's really a design. You're designing it from the start. And most things in most colloquial or current fashionable uses of knowledge graph, people are coming from the other direction, right? Where, like in our project, we are saying that, okay, what can we automatically extract? What relationships we can get from the crowds, right? And in the phase two, in the part two, if we get time in today's presentation, I can explain to you how we are choosing the relations to extract. And there is some thought, some ontological design behind what those relations should be. But the driving factor here is, what can we extract inexpensively and in a scalable manner, right? And ontology does play a role, but it's not like, we're not saying that, okay, well, we need to build a ontological model of the whole book, right? It's more of the process, but ultimately, because it's a book, we want to answer questions. The goal is to end up with a formal representation that is precise, that we can reason with, we can answer questions, etc. So have I answered your question?
Yes, so far, yes. And we'll have more opportunities, but there are others after me waiting.
Okay.
Thank you.
Okay.
Ram, you're next.
Yeah. Can you hear me?
Yes. Yes, we can hear you.
And let me first at the offset say this is a very exciting piece of work. And, this is also a step. I should admire your courage for trying to attempt this kind of a thing because it's a lot of work, as you know. And the question that I have is that the Halo project, you had a considerable amount of kind of knowledge graphs in a way, those kinds of things built in there. Are you reusing any of that information, that any of the things that you've gained from there? Because that effort was for quite some time, I thought.
Right.
And the other thing is that what is the ultimate goal? There's another thing in terms of the ultimate purpose of this whole thing. Because when you talk about intelligent textbook, it's more than what encoding knowledge like this. There's a lot of problem solving going on. Like, for example, if you go to Campbell's textbook, at the end of each chapter, there's a list of questions that are asked. And the questions are not straightforward as, where is the, what is that, nucleus in a cell, or where is the ribosome, and what's a ribosome? Those kinds of things are different, but they ask some tricky questions in terms of when you're trying to explain, for example, the mechanism where you go from RNA to proteins or DNA to proteins and all those things. And there's some tricky questions that are asked in these textbooks. Is there a goal of eventually trying to address those kinds of things so that you can help the student through the pedagogical process?
Okay. So there are several things you are raising in this question. And the first part is, what are we using from what we learned in Project Halo, right? There is that question. And then the second question is, what's your goal? Where are you going? What's your vision, right? So I'll take both of those questions in turn. So regarding Project Halo, one of the outcomes of Project Halo was this intelligent textbook prototype and this claim that we make that it leads to 1 full letter grade improvement in learning. That result is from Project Halo. And we are using that as the foundation for proposing this project by saying that, hey, if you use knowledge graph in a book, there is a use case for it. Somebody will benefit. And in the demo, I showed you some examples of the kind of things pedagogical tools that we can build in the book. They seem interesting. At least we had quantitative data to prove them. The $1.5 million number also is from Project Halo. I mean, again, if you ask the project team members, they would say 1.5 million is a underestimate. The actual cost is actually much higher. But again, even if we are being very optimistic and very generous to our technology, it's actually not a bad number. But when we take this number to publishers, they're not willing to look at this as a serious technology to add to their offerings. And the issue is the scale, right? How are we actually going to scale this to 41 books and to 200 books and then to all the books? I mean, that path is not clear, right? So all of these things are learnings from Project Halo. The other things that we are using from what we learned there was, we have this ontology design. We had component library. We had a lot of domain-specific ontologies. And so what we did was we went through our knowledge base and we looked at what are the things that were being used in the ontology. And then we sort of pulled out those useful things, and they are the basis of the relations we are extracting in this project. So a lot of wisdom that we gained from Project Halo, we are feeding that into this project so that we're not starting from scratch. I mean, I can say more about this, but I would just move to the second question for now.
Yep. Thank you very much. That's fine.
Yeah. So the second question was, what's the ultimate vision? Where are you going? So, I mean, again, I think the cost kind of became a sticking issue. And when we show the demo and prototype to the publishers and teachers and students, they tell us that, hey, currently the books that we have, they use almost zero knowledge graphs, right? I mean, right now they're building these PDFs and that's it. You know, I mean, they have a glossary at the back, but even that glossary is not a term list as ontologists would think about it, right? So the current state of the art of the use of knowledge graphs in the books is, from ontologist's point of view, is on a fairly low end, okay? And so we said, okay, well, can we, unless we can have an impact on that, you know, this whole thing is going to just sit on the shelf. And that actually requires us to find a problem where we think this technology can make a difference. And the way the problem is stated here is that biology is complex, book has lots of new words, and students are lost, right? So I mean, this is a real problem that people have. And we feel that if we can take the glossaries in the books and we can turn them into term lists, and if those terms have some relations defined on them, that will help solve this problem. Or at least it's a tool that people could start experimenting with. Is that as good as answering all those complicated questions, or is it as good as the Project Halo vision of, oh, you know, the computer has understood the book as well as a human does? No, it's not, right? And I mean, that is still a valid and very interesting vision and a goal. But as I started off by saying at the start of the project, that the Convergence Accelerator is trying to take an innovation and reduce it to practice. So within this limited 3-year project, what we're trying to figure out is that whatever we did in Project Halo, can we reduce it to practice? And then other big question we need to answer is, okay, even if we can reduce it to practice, is there a sustainable path, right? Would publishing industry jump on this, and would they start putting knowledge graphs in all of their books, right? Would that happen? And can that be sustained, right? So that's what we are trying to achieve with the Convergence Accelerator project. Scale, economics, sustainability, right? If we can achieve those three things, I would think we would have moved the needle, right?
Thank you very much.
Yeah, so one final point, the idea of understanding the books, I mean, I think it clearly fits in the NSF's portfolio, and NSF has these AI institutes where they are wanting to attack some fundamental AI problems that are also use inspired, and we are hoping that some of those difficult problems can fit in the AI Institute portfolio, and we don't lose sight of the hard AI problems also. Yeah. Okay.
Okay. We have a lot of people waiting in line. The next person is Terry.
Okay.
Terry? You need to unmute yourself.
Right. I was looking at the chat instead. The question is in the chat, and it's a little the way I typed it in is kind of confusing to me. But the question really is, you're talking about creating the knowledge graph and the system with an existing textbook. Have you got any thoughts on how you might go about doing this as the initial creation point for a textbook online?
Yeah, so there is this idea of building publishing tools, right? So for example, could we provide a tool to a textbook author through which they can systematically manage the new words that they introduce into the book, right? And could we build a tool which can analyze just the text definitions of like in the glossary they have definitions, and are these definitions circular, right? Are these as Barry Smith would like to say, are these definitions Aristotelian, right? Could we write a program to check whether a set of definitions follows Aristotelian principles, right? So some of those things, if we can start putting into the hands of the textbook authors, then some of the knowledge graph construction process becomes part of the publishing or authoring workflow, right? At least that's my vision, that eventually, again, we have to start with the end user, which is the student, right? We have to start there, but we have another diagram, which I don't show here, is all the stakeholders in the whole process. And that includes authors as well as publishers, right? And some of that knowledge graph construction process has to be taken over by all those stakeholders who are involved in producing the content. Did that answer your question?
Terry, is that okay? All right, well, we'll move on to John.
Okay.
John, you're next.
Okay, I was just mentioning the work that we had been doing with VivoMind, that Aaron Majumdar had a fantastic invention for this system that we call cognitive memory, which automatically relates whatever it reads from any documents to its knowledge base, and with logarithmic time access to a huge to an unlimited sized graph base. And one thing that we did in cognitive and at VivoMind was have some very good programs where the system automatically built its own ontology of the subject matter while it was discussing the problems with the people who used it. And one of the largest examples was for oil and gas exploration, where the people who would use the system are geologists who were who were working their way through a set of research reports. And to get the ontology, to derive the ontology for reading the research reports, the system would read textbooks from which it would derive graphs that it would use for interpreting the research reports. And as the people who use the technology continue to use it, it would automatically construct its own ontology as it goes along. And the more it was used, the better and better the ontology would get. And if you went through exactly the same questions a second time, it would get better answers, because it would have it would use the set of ontologies that it had built up from the previous interrogation.
So John, I have great respect for you, but at the same time, if you can do everything that you're saying, why are you not a billionaire?
Well, one thing that happened to that project was that unfortunately, fortunately, the oil market crashed, and that project went out of business. However,
every industry needs it. All the web companies need it.
However, the company was building a very large number of applications that were being paid for by the various government agencies, and those documents were confidential, so it's not possible for us to show examples.
So again, John,
yes.
Technology can be applied if you really have the technology, which is general purpose. It can be applied to any domain, and if you can apply it to domain, Google wants you, Microsoft wants you. You know, you should be a multi-billionaire if you can really do it.
We did talk to Google, and One thing is that the answer was that, well, it looks complicated and it wouldn't scale to the size of the internet. And that is false, but it was simply that they didn't understand the problem.
Okay, so anyway, again, that was a facetious way of answering the question, but I can, the real
Am
ground.
I the only one losing the audio?
Pardon?
I think people can hear it. People are able to.
Okay, please read that cogmem.pdf directory.
No,
Those are applications that were paid for by customers. They weren't research projects. They were applications for which the customers paid.
Yeah, that's fine. I mean, again, I think I can tell you, I can answer that question from my own experience and what I have tried. And so in this slide, you're seeing a very simple term extraction task. Okay, so I have a book, and from the book, I want to build a glossary, which I can use as a term list. Okay, so the current best state-of-the-art BERT models, which are used all over the place these days, they have a precision of 0.71, and their recall is even lower. And this level of performance is very good for a lot of applications, right? And these guys are multi-billionaires, right? So I mean, BERT is used all over the place. If you read the literature, everybody's using it. And the thing that I want to convey is that for textbook, the accuracy requirement is 100%, maybe 99.9%. It's right. You need a very accurate model, because right. if your model is not accurate, people are going to throw it away.
Absolutely. And
okay.
That's also in that CogMem. Look at the first example. This is the one on legacy reengineering, where the system analyzed 40 years of documentation by this company, Towers Perrin in Philadelphia, and also analyzed the software that was written in COBOL and IBM's job control language, and it related the documentation to the work, to the documents, and it created a glossary of all the terminology that was used for those past 40 years, with the changes in terminology as it went along. And it produced one CD-ROM with all the data, which is what Accenture said would take 40 person years to develop. And this project was implemented by Andre Leclerc and Aaron Majumdar in 15 person weeks.
Okay. Now, so John, do you have a open source tool I could download and try?
No.
Or even a commercial tool I could download
there are a number of issues and very painful problems and of all kinds of politicking and problems. But the point is that the major funding of this was done by various government agencies, for which the tools were basically done on an application at a time basis. However, there's ongoing work to make this commercially available. But that will take, taking a project that's consultantware project to applications that you can send out for anybody to use, that takes a huge amount of, an order of magnitude more work to provide stuff that anybody can use versus applications where you develop one application for one customer for a particular purpose.
Okay, thank you. Well, maybe you should have applied for the Convergence Accelerator, or whoever is working on those tools, they should have applied for this project.
Well,
I think
the politics in this is huge, and there's a lot of stories for why this did not, why this company had gone up and down various ways. It's the short story is Oracle could become a huge company back in 1970s. Today, the big companies do everything possible to destroy little companies. They do it.
Okay.
So yeah, I mean,
thanks, John, but we have a lot more questions, and I'm afraid we have to move on.
Sure, please. Maybe I like to make one concluding remark, that I think our effort has been to look at to leverage widely used open source tools and make use of them. And that's what we are doing with BERT. And this is I think we're using the latest and greatest and the best technology that we have publicly available to us on this project. Okay.
Okay, Leah.
Hi, this is Leah. Thank you, Dr. Chaudhri, for your presentation and sharing your overview paper. I have two questions, so I'll ask them both and hopefully you can divvy up how you answer them. My first question is related to the usability testing that you're doing for the project. And I was curious how you're selecting students and if you're including other professions like, if the professors, teaching assistants, librarians, others in a department that might need to facilitate delivery of the textbooks to students. And in regards to students themselves, making sure you're getting a cross-section of people maybe with learning disabilities, people who are reading English as a second language, any people who are visually impaired, how are you addressing those needs? And then my second question is to something that you mentioned briefly later on in your presentation, which were the two other examples of applications of knowledge graphs, which were the learning about contracts in a legal setting, and then the IRS. And I was just wondering why you had selected those two examples to kind of correlate with this textbook example. I see, providing information to students in the learning environment is, kind of is a completely different use case or type of use case from assisting professionals in a very specific kind of enforcement or legal transaction or contract transactional mode, kind of a process professional mode. So I was wondering if you could address this too.
Yeah, thank you for those questions. They're both great questions. I mean, this is actually one of the first NSF projects I've been involved in, and NSF plays a very strong emphasis on broadening participation, right? So broadening participation means, being able to develop and build tools and technology for a wide cross-section of audiences, which includes all the people you're talking about, people with learning disabilities, with other kind of disabilities, or people from different cultural background, different racial background. And I mean, in all the work that I have done until now, we have not taken those issues into account. But for our phase 2 proposal, we have a section where NSF made that a requirement that we have to address broadening participation. And so the user research that we are going to do as part of our phase 2 is going to look at those issues. So we are going to go and talk to people with different backgrounds, people with disabilities, people. So all those special groups that you mentioned. So I'm acknowledging that our work until now has not addressed that, but in our phase 2 work that we are currently proposing to NSF, that is an explicit component of our work. And actually, I'm interested in other ideas on how you think we might do it. As we were writing that section of the proposal, we said we will just expand our user research. We will go and talk to broader. We will explicitly pay attention to different profiles of people. If there is another way of incorporating participation into our development and design process, I'm very interested to hear from you and talk to you. Regarding your second question, why we picked contracts and IRS, I think one thing for which I feel there is lack of appreciation is what you can do with the knowledge graph, like what kind of computation you can do with it. People make the claims like, oh, we can automatically process the book and we can do this knowledge graph or ontology using it. But the point is that, okay, what's the actual end performance task for that? And the income tax example actually makes it very clear, right? if you can automatically process all the IRS publications and automatically create TurboTax, wow, that's pretty cool. You know, I mean, there is a huge industry out there. There are people like TurboTax and H&R Block, and there's a large number of income tax managers. This is a key problem they have, right? Because the regulations keep changing, and they need to deliver software that can precisely and accurately calculate your income tax. There is no, how would you feel if TurboTax told you that, okay, I'll give you your income tax return, but it's only 71% accurate, right? I mean, you don't want that software, right? You want 100% accurate, and in that sense, it's a very close analog to what we are trying to do with the book, because with the book, you know, you want your teacher to be 100% accurate. You want your teacher to know exactly what is true and what is not true, or where the exceptions are. Your teacher is expert, right? They have accurate model of what's in the book. In the same way, for you to do income tax calculations, like if you're a chartered accountant, you need a very precise understanding of what the IRS regulation is, right? You can't fudge around with it. And same argument can be made for contracts, but I hope you see the analogy.
Yes, thank you. And I just want to quickly say, I missed last night's session, but I want to thank you for facilitating the knowledge graph class at Stanford. I've been learning quite a bit of information by sitting into those sessions. So thank you. And thank you for your presentation today.
Sure.
So next we have Mike Bennett.
Hi, this is Mike. So a very quick question. Wondering what you see as a possible role for foundational or cross-domain ontologies. I think in particular, like the distinction between a thing in itself and a thing in some context, like a catalyst, or, you know, the same person being a doctor or a patient. The reason I ask that is if you're doing bottom-up discovery, or, you know, sort of that kind of harvesting type of approach, you can often end up with a brittle ontology that doesn't make those distinctions. On the other hand, maybe if each book has its own standalone ontology, perhaps that's not an issue anyway. So I'd be interested in what your thoughts are on that.
Right. I mean, foundational ontologies clearly have a role to play, and they are very, very central, right? And we did quite a bit of work on this as part of Project Halo. I also had done some work with Brendan Bennett at Leeds, who helped us design spatial ontology. We have some papers on how do you do structure, how do you do function. We spent a lot of time reading BFO papers, and some papers from our Italian colleagues on Dolce, just trying to understand what is their perspective on what are the right relationships to use. Now, one thing which I think Barry Smith can tell you very well is that it's fine to have these philosophical distinctions, but when you take these distinctions and you put it in front of a biologist or a domain expert, they don't immediately understand those distinctions, and they don't even understand the importance of those.
That's right.
Those distinctions, and that's partly the cultural work. And we have to address the same thing in our biology textbook work, because from the upper ontologies, we say that, oh, you know, you need to make a distinction between what's a part versus what's a region, right? So it's a very fundamental distinction. But when you explain this distinction to a biology professor, and they say, why do I need to have this distinction? So, and so part of this process is cultural, that, okay, I mean, the way I explain to them is that we are going to make learning biology more computational, and this computational skill is more important for your students, and that's why it's a good idea. You should make these distinctions.
Good.
But it's not obvious that those distinctions are natural to them. But there are other things like input to a process, output to a process, what participates in a process. I mean, those things they understand, and there you have less resistance on acceptability. Hope I answered your question.
Thank you. Yeah, you've reinforced the importance of facilitation to get that ontology right. So it's very interesting. Thank you.
Okay, Steve Ray.
Yeah, hi. Can you hear me?
Yes.
Yeah,
I had two questions, but Leah asked the first one, so I won't ask the one about the students. My other one is also not specifically a technical question, but more of a sort of a political question. I noticed you had Macmillan as one of your collaborators, I guess, the publisher.
Yeah.
And what is your impression about the pushback on the part of the traditional textbook publishers for this movement, which is going to have a whole different business model? I mean, obviously the textbook publishers make a whole lot of money printing and selling a new edition of a textbook at great expense to the student every year. So what are your thoughts on that?
Yeah. So, I mean, at some level, those thoughts are not different from thoughts on business models in general, because you know, we have open source software and we have commercial software, right? We have both, and there are highly successful open source software and there are highly successful commercial software. I mean, there are both, and there seems to be room and place for both. I mean, I think in the context of our NSF project, what we are saying is that we want to build this textbook open knowledge network token, and we want to make it available for free, and we want to open source it so that anybody can use it.
Those tasks can be solved.
Yeah, I guess sort of related is, I was just wondering if you had any thoughts on perhaps in a positive way, how people could in fact make money out of it through either paywalls or leasing access or things like that, if it wasn't for free.
Oh, well, so we've had conversation along those lines with our partners, and again, the answer is not very different from software in general. So in theory, a commercial publisher could take our free knowledge graph, and they could improve it, they could extend it, they could build. For example, one of our partners is Educational Testing Service, right? So they have 20, 30 years of research on automatic question generation. So, and they have a lot of algorithms that they've developed, but the missing piece for them is the knowledge graph, right? Mm-hmm. So they could take our knowledge graph for free, and they could they could use it to power their automatic question generation algorithms. They could customize the knowledge graph to their needs, and they could make money out of it, right? That's one example, right? Mm-hmm. Where people take free, and that's not different, right? So I mean, people take free browsers, right? And
yeah, okay. I was wondering if you had any sort of new twists on the whole idea. Okay, thanks.
Okay, Gary, go ahead.
Yes, I have a question that relates a little bit to the ontological realm. Parthood is obviously a very important part of biology, but it's also an important part of other domains like manufacturing. Yet we know the ontologists look at parts differently in different domains. And I'm wondering what your going in position has been, or what you've learned as part of the effort.
So at least within our project, we've been, until now, have been looking at a variety of books. And our going in position has been that whatever ontology that we have, that will most easily generalize to first life science domains. So like if you're in biology, you can do different books in biology at different grade levels. And then maybe you can do neurobiology, maybe you can do biochemistry, chemistry. There, the generalization would be much easier. And given the adoption of this technology is so low in these domains, even if you do this basic generalization, even if you can make that happen, that's a revolution, I think. But also then there are things like, what's an experimental method? How do you draw a conclusion from data? These things do show up in the textbooks, and those things are fairly general across domains. But again, there are differences too. Like for example, if you look at experimental methods in psychology, they have slightly different way of doing things than biologists do. So each field is going to have its nuances, and what I have found useful way to think about this problem is, let's for a moment separate ourselves from the book, from the ontology, that whether we can use our ontology into in different disciplines. Let's just think in terms of the books. Okay, so let's say I have a book in which in biology where I'm going to talk about experimental methods, and then I have a book on psychology where I'm going to talk about experimental methods. Am I going to use same words, right? Am I going to use very similar sentences? Could I take section on experimental methods from a biology book and plug it into a psychology book?
It can be done.
It can or cannot be.
Look at those things. They were.
Cannot be.
Well, at some level, it can be done, because if you think in the university context, there is one course on experimental method, which people from many different disciplines can take, right? So I mean, there is, again, I'm not sure if I'm making any useful sense here, but all I'm saying is that there is a level at which the knowledge is general, and you can share it across domains, which is illustrated by the way we modularize it in courses in a university.
I would just add that some fields like ecology incorporate concepts from multiple domains. So you have spatial parts as well as animal biological parts to consider in there. So some domains are more interdisciplinary and a bit more challenging, perhaps.
Right.
Okay, Ravi has a question again. Ravi, you still?
Yes, I'm unmuting myself. Again, I'm coming back to Vinay. And Vinay, I think the problems that are already solved, for which commercial software is available and adequately works for millions of users, like for IRS and also electronic contract execution among financial and manufacturing and supplying people, have been working for 20 plus years now, or 15 years. There is nothing that much new that this new thing can contribute, although you can spend energy on it. But what I feel is most exciting about your work and your team's work is the ITB token way of learning. This will prove to be a path breaker, a jump start in knowledge engineering, in the way students learn in future, in the way professional people apply your techniques and technologies to do new projects, new products, and especially, as Gary mentioned, interdisciplinary projects and products. Because right now people are stuck with just referring to several individual works like textbooks or published papers and things like that. As you refine these aspects in your ITB and token, you will bring use of new ways of using knowledge and learning. That is the strength on which you should concentrate. Second is some question asked by, I think, Leah, but I'm repeating. How are you filtering in crowdsourcing people you are using to validate whether your answers are relevant, accurate, and on the dot or not?
Well, thank you very much for the validation and the endorsement. I agree with you that the strongest work we have is with the intelligent textbooks. It's concrete. It captures a lot of people's imagination, and they can see the value for it. And we are very excited about that we have an opportunity to keep pursuing that. And in all fairness, I mean, I am currently involved in projects on computable contracts, as well as I've done some work with the income tax industry. There are clearly needs there, right? It's just that we don't have yet an equally compelling demo that we could show, which could show the benefit of this kind of approaches. We don't have that demo yet. Okay. But the need is there. It's definitely there. Regarding your question about how do we filter people, so there is this technique in crowdsourcing that people call gated instruction, where they would first put people through some exercises for which we already have expert answers, and based on their performance on how well they do on those tasks, they get calibrated. They kind of get a grade as a worker, and based on that, they get fed. They get to either perform the future tasks or they get kicked out. I mean, that's one technique that we use. The other technique is you can rate the worker ability in relationship to the task, and that's what our denoising model does, where we compute the inherent difficulty of the task and the inherent capability of the worker, and over a period of time we send more difficult tasks to workers which have higher capability. That's another way of doing it.
Thank you. That answer.
Yeah.
Janet?
Janet had a question, although she took down her hand.
Yeah, hi. Thanks. This is nice to see. I wrote in the chat a specific comment about the presentation, but I do want to make a more general point about your seminar, which I've attended the 8 weeks of and been very impressed and pleased. And the thing that has struck me most is that the knowledge graph world has really left, if knowledge graph world is the student and ontology world or AI world is the teacher, the knowledge graph world has left the teacher behind. And it is time, I think, for people to, in the ontology community, to revisit what is it that we can add to the knowledge graph world, because as you're saying, the knowledge graph world is massive and value producing, and they're doing everything that is usually attributed here to ontologies, and they're usually doing it without using the O word. And I've been struck by how few times ontology has come up. I still think that there are specific things that that ontologies can do, but we shouldn't continue to act like every domain theory, every world model, every whatever has to be called an ontology. We should try to narrow what is it that ontological thinking can add in value to the what is being done in KGs. So thanks for the class, and been very informative.
Thank you for that endorsement, Janet. It's gratifying to hear positive feedback, and thank you for showing up.
We've run a little bit over, actually. So I'd like to adjourn the meeting. Thank you, Vinay. That was really very, very nice. We never ended up actually having a second session.
Maybe at some other point, Ken. I think
maybe at some other point we'll see.
Yeah.
I think it's just been it sounds like a really marvelous thing that you're doing. I think this will bring together communities that have not yet been engaged in this kind of knowledge development, knowledge graph development. And so I hope that this gets funded and you'll be successful. So now next week we're going to be having we're going to be having another session on use cases with Yolanda Gill, and I hope all of you will be able to join us.